So as we enter in, before we kick into the theory, we'll just talk a little about what we understand by a rate of reaction. Rate of reaction is how fast things are going. Why is that important for a chemist? Why is it important that we know how fast a reaction is going to go? Think about industrial processes.
Oh, so that they're efficient.
Yeah, well, I mean, yeah, absolutely. It's no good if I want to if I've got a reaction, it's no good if it takes 200 years for me to get my product, is it? I'm not going to make a lot of money, I'll be dead. So what I've got to do is I've got to get a reaction which is going to actually go fast enough for me to make it. So as a chemist, if I want to do a reaction, I want to know how long it's going to take to do. And if I want to speed it up, I need to know how I can speed it up, what things I can do to speed it up. So this is a very typical reaction. So I have got here some calcium carbonate. So just some calcium carbonate in here, and I'm going to add some acid to this. And it hopefully will go quite fast. So here we go. So in goes the acid. There we go. So I have got, can you hear the fizzing? That's quite a fast reaction. How could I measure that? How could I measure the speed of that reaction here?
The amount of gas in you.
Brilliant. I can measure how much gas is given off in a certain time. So if I did that, what would my units be if I measured that? My units would be, if I measured it, it would be maybe in centimetres cubed of gas per second. What else could I measure? That's the gases given off. I added some sulfuric acid in there. What else could I? What's happening to the concentration of sulfuric acid as it reacts with the calcium carbonate? The equation is sulfuric acid plus calcium carbonate gives me calcium sulfate plus CO2 plus H2O. Then I could measure that way. What's happening to this? The concentration is decreasing, so I could also measure how fast my concentration of acid is decreasing. If I did that, what would my units be? Concentration is measured in moles per decimeter cubed. So I'd measure the change in concentration with time. So it would be the change in moles per decimeter cubed per second. In the same way that this would be centimeters cubed per second. So it's a change in concentration or volume, something that I can measure over time. And that's how we're going to be measuring rates of reaction as we go through. So if we just say the rate of reaction measures the amount of a given chemical either used up or produced in a given time. E.g. So this was the reaction that we did, calcium carbonate plus sulfuric acid gave me calcium sulfate plus H2O plus CO2. So for this one I could measure how fast the concentration of acid decreases. And my units there would be moles per decimeter cubed, which is a -3, per second. Or I could measure how fast CO2 is created And in that case, if I measured it in centimetres cubed, it would be my volume in centimetres cubed per second, like so. So they're different units, so you kind of get your head around the fact, just look for the per second bit. You can do it per minute if you like, but generally per second. Obviously, the key thing is you actually have to state what you're measuring. So if you're talking about rate, you have to say whether you're measuring how fast the rate with how fast CO2 is produced, or how fast the concentration of sulfuric acid increases, because otherwise it doesn't make any sense. So you've got to talk about which one you are